Hi, this is my final presentation for the KaggleX apprenticeship program for cohort 4. So my name is Jorge Rocha Campos. I'm a former mechanical engineer, now turned data scientist. I received my bachelor degree from University of California, Irvine, mechanical engineering. I'm a first generation college graduate, and I currently reside in San Diego, California with my big dog Benji down there. So, Learning Prep Index. Learning Prep Index is essentially the source hub for data science and machine learning courses, where it's designed to make navigating courses faster and more efficient for beginners and experts of all levels. And I chose this project because it aligned to my interests in tutoring and education sector. And I would be working with a team rather than individually, working with project leads and also different team members. And essentially, this is a little bit going a little bit more about the purpose of LPI, but cutting these courses into videos and modules instead of how to take little courses. You can just choose the courses that you want based on the concepts you want to learn. So what I contributed for the project is essentially I was experimenting with advanced RAG and fine-tuning a model. And what I did is I used Gemini tool for the models for the advanced RAG and fine tuning. And I was generating the conversation data set with Gemini 1.5. So let's go into what is RAG. So what I did is compare naive RAG with advanced RAG. And the key differences is that advanced RAG has optimization steps. So the first optimization step is pre-retrieval optimization, which is what I did is include metadata of these courses to make the filtering of these courses more relevant when you're inputting into this context window. It makes it easier for the model to filter the reasoning model. And the reasoning model I use was Gemini 1.5. And for the retrieval optimization, I use an embedding model from Hugging Face. I just found this to be the best and fastest model to use. And I also included hybrid search that combines vector search and keyword search. This was the best case I use. I was playing around. I used precisely just vector search and keyword search, and I had mixed results. But when I combined them and I did a 50-50% vector and keyword search, I found this is the most optimal route. And for the last optimization, the post-retrieval optimization, I use a technique called prompt compression. And for the prompt compression, what it essentially does is reduces the size of the prompt inputted to the query, the query of the model, and only grabs the relevant keywords to input to the model to find these relevant courses. And you will see an example of this later on. So here's an example in NeRAG. This is a sample query I used. And when inputted into the model, it retrieves two of the relevant courses, the Google Developers and the Learning AI, but it doesn't return a structured output. So how do we improve this? How do we improve the structured output? Well, I use advanced RAG. In the RAS rag, I included a few shot problem to make sure that the model would output this template I give, this tabular table. And when I did Fuchs shot, which uses an example, I retrieved this tabular form of these two courses with development information for each of these courses. And you can see in the top in the output, it says using query string fine-tune. This is the prompt compression where it grabs that the keyword that we need to use to search is fine-tuning. Now, for the fine-tuning, I first need to generate this Q&A data from the LPI data set. So what I did is experiment a lot because there's not a lot of documentation on how to generate Q&A data. So I found that using Gemini 1.5 Flash on Vertex AI, I got the best results since it's a large model. And I used a lot of prompt engineering since there's a lot of testing playing around to see what is the best prompt to get these consistent results. And after doing a lot of prompt engineering, I had to include some post-processing techniques since the model would sometimes hallucinate and forget things or just not finish a Q&A set. So that's where the post-processing techniques come help ensure the data quality. And these are examples of the data set, turns to tabular form based on the question. Now, when testing the fine-tuning model, I first test the base model without the fine-tuning, and when I input a question, I get returned this output, which it hallucinates. It hallucinates, it returns an answer, and it keeps on repeating the answer, which ideally we don't want. And when we fine-tune a model, we retrieve a more structured output of the tabular form that we desire. And also return courses from the dataset, but it repeats and it hallucinates and keeps repeating these courses. And you can see when testing and comparing the courses from the vector database with the courses returned from the model, some of these courses aren't in the vector base, so it's also hallucinating. So when comparing the two RAG fine-tuning, I conclude that RAG is a better alternative for this use case since fine-tuning requires a lot of resources and compute resources. And for this use case, as we continue to grow our record database and we get more and more and more courses, we will have to continue fine-tuning this model and continue retraining, which isn't ideal. When in RAG, we just have to store in the record database and augment it to the context window. And now let's see an example of a demo. And these are the links for all my notebooks that you can test out, including the demo. So when testing the demo, that's the notebook. We see that when I say, hey, hi, I want to learn about fine tuning, what should I take? And return this tablet form. And before I leave, I want to shout out to my mentor, Emmett Rudy, and my project leads, Manny Sakar and Emmanuel Cachi, that were so helpful the past 3 months. Essentially, I felt like I had three mentors. Thank you so much. Shout out to you guys. And thank you for watching my video. Have a good one, you folks.